Hey folks, this week we're going to be talking about fingerprinting. Now, I had waited so long to do this one with the hope that we would actually be back in class to do fingerprinting in person. Um, so, sorry about that. So, the first person to really identify fingerprints as a means of identification was Sir William Herschel. So he was a British officer serving in India, and he was using fingerprints for contracts. He started collecting them in 1856 and noticed that each pattern was unique to an individual. They didn't change no matter how old you got, they stayed the same. He also invented the mugshot. So there's the man himself with, basically a rudimentary mugshot. And it was taken 120 years ago. Isn't that fun? Sir Francis Galton and Sir Edward Richard Henry developed the fingerprint classification system that we still use in the US and Europe today. So let's talk about fingerprints. Fingerprints are technically called friction ridges, so basically we've evolved to have fingerprints because we need that friction if we're going to be picking up things. It makes it a whole lot easier if you have fingerprints. So they help us grip objects, and the imprint of a fingerprint has secretions that are made by sweat glands and pores that are present on the friction ridges. So if you get a very good fingerprint, you can actually see where these secretions come from. And, they're mainly going to be water, but then you have oils, salts, and amino acids that are also secreted by those glands. So fingerprints form when you're about 10 weeks old. So, very, very early in pregnancy do we have fingerprints. And they're created in the basal layer. So basically, we've got the upper layer of the epidermis, and then the basal layer is in between the upper level layer of the epidermis and the dermis itself. And since the basal layer grows faster than the epidermis that's outside of it, and the dermis on the inside, then the pressure causes it to collapse and fold in different directions. And the crazy thing is, even twins are going to have different fingerprints because it's kind of caused random. There's 3 different types of fingerprint evidence that we can collect at a crime scene. This is different than the 3 different classifications of fingerprints, so whorls, loops, and arches. When we talk about these 3 types, we're talking about basically how that fingerprint's been left behind. The first way would be a patent fingerprint, so a visible print left on a smooth surface by blood, or ink. So if you had blood, ink, paint, something like that on your hand, and then you touch a smooth surface, you're going to leave a fingerprint behind. Kind of the idea behind when they, were using thumbprints for contracts, or, in some countries you need a thumbprint to vote. So we've also got what we call a plastic fingerprint. So that would be an indentation that we leave in a soft material. So this would be something that's actually pressed into the surface. And this is going to be fairly rare. It's not like, oftentimes we have criminals using Play-Doh at the scene of the crime. But, stranger things have happened. And then most commonly when we think about fingerprints, it's latent fingerprints. And these are those oils that we talked about from the secretions from the friction ridges being transferred to some other surface, which we can then make visible by either dusting them with powders or using some sort of chemical reaction. So in a movie, hopefully only in movies, when a criminal wipes down a weapon or wipes down the door or uses fingerprint or uses gloves, they're trying to either wipe off their fingerprints, or they're trying to not have their fingerprints stay on that surface. So when we talk about latent fingerprints, we want to be able to visualize them. And there's a lot of different ways to do this, but the most common way to do it is to dust the surface. So when we dust the surface, we're going to use a colored dust, and we want to pick a color that contrasts with the surface. So if we had something that was white, we would want to use a dust that is black. If we had a black, so if we were back in school and we're dusting for fingerprints on the surface of the lab benches, we'd probably want to use a white dust instead of a dark dust. So once we do that, when we find a fingerprint, and basically what happens is the dust gets trapped in those oily secretions, then we can use tape to lift that fingerprint off, and the tape's going to preserve that fingerprint fairly well. Then we place that on a card to preserve it. And we can also use magnetic powders. We can also use fluorescent powders, basically based on what it calls for in the situation. Now, once again, this is one of these things where I wish we were in class right now, getting black dust all over our hands. Oh well. We can also talk about the chemical development of prints. And this is another thing that, had a lot of things planned. But basically, the amino acids in the sweat will react with several different things. So commonly, we have cyanoacrylic vapor, which is superglue. So this is a method called superglue fuming. And basically a small amount of superglue is placed on a cotton swab that also contains sodium hydroxide, and then when that heats up, it creates a vapor. That vapor will basically preferentially attach to where the amino acids are, and then you get a fingerprint basically made out of super glue, and that works really well for any sort of hard surface that you can actually take and put in the chamber that you fume it in. The other one's ninhydrin. Now, I bought a couple bottles of ninhydrin spray. Ninhydrin works great on paper. So if you touch a piece of paper and then you spray ninhydrin on it and you wait, there will be it's a fairly slow chemical reaction. You have to wait for the ninhydrin to dry, but you get a purplish fingerprint left behind on any fingerprints on the paper. We can also talk about reactions with the salt in your sweat. So one of those they use is silver nitrate. We would not be doing silver nitrate in school because Wake County has taken away all our silver nitrate, and that happened fairly recently, like within the last 5 years. So silver nitrate will produce a precipitate, silver chloride, when it reacts with sodium chloride, and then you can view it under UV light. We can also talk about the carbohydrates left behind, and that is when we would use iodine fuming. So iodine fuming is another method where you basically take the object that you suspect to have fingerprints on it, you place it in a chamber with iodine, the iodine vapor then attaches preferentially to the fingerprint, and it stains it this kind of amber color here. You need to, now iodine will naturally kind of dissipate after a while, so you have to spray that with a starch solution to preserve the fingerprint. So here's a breakdown on a bunch of different, or all the different ways. So ninhydrin, like I said, works well on paper. You spray it or dip it. You can't inhale it, you can't get it on your skin, you have to do it outside. And then that reacts with the amino acids and you get a purplish blue print. Cyanoacrylic vapor is great for basically anything that is usually solid surfaces. You heat the sample up in a vapor tent, but once again, it's not something you want to breathe in, and that reacts with amino acids and produces a white print. Silver nitrate works well on wood and styrofoam, so things that are a little bit more porous. You either dip it or spray it or wipe it down with the silver nitrate. Silver nitrate Wake County won't let us have it because it does have fairly high toxicity. And then the chlorine from the salt will combine with the silver nitrate to form silver chloride, and you get a black or reddish brown print. And then iodine fuming works well for paper, cardboard, or unpainted surfaces. So once again, that's kind of your more porous surfaces. You need a vapor tent and solid iodine crystals, and it's very toxic to inhale. So you get a brownish print that fades quickly that you either need to photograph or spray with a starch solution. Now, fingerprints can be altered. So we're looking at John Dillinger right now. Basically, he was a gangster back in the 1930s, did a lot of bank robberies. He heard that Cuban pineapple workers had their fingerprints destroyed by the chemicals in the plants. Basically, pineapples are really acidic, and it was eating off their fingerprints. But the workers' fingerprints grew back. So they would put acid on their fingertips to change their appearance. But in the end, so even though he had done this, it still matches up with what the crime scene evidence was. So Dillinger wasn't taken alive, but they were still able to pin the robberies on him because even though you're altering your fingerprints with the acid, now you're the person with the acid burned fingerprints. So, unless you convince like everybody to do that, it's not gonna stop you from being accused of a crime.